Hello. We looked at a few different scenarios. We looked at water as ice and a chunk of ice, the temperature there. And we looked at ice water together. And we looked at boiling water and steam. So I want to take us back and think about the ice, the block of ice, and the water and the ice. And we saw that those temperatures are the same. So for this experiment, just my hands, we're going to need to kind of model this and just see what's going on with the molecules here. And so I have my fingers here. I put some blue tape on them. So if you have some blue tape or some marker, you want to color your fingers or just use your fingers, that's fine. I'm using my fingers as water molecules. So I have some water molecules here. And they're moving around. Okay, so the water molecules, this is in ice water. So 0 degrees, right? So ice water, the water in the ice water was 0 degrees, and they're moving like this. Okay, now we also had the ice at 0 degrees, same temperature, right? So are they really moving any differently? If it's the same temperature, we have ice at 0 and water at 0. What's different? And so we know that kinetic energy is the same. It's pretty much the same. It's the same temperature. They're moving about the same. And so something else is different here with the molecules, and we know that ice, it's a solid, right? You can tap it, you can hit it. It doesn't move around, it doesn't like wobble around. And so let's do something to kind of show that. So what you're going to need for this experiment is you're going to need some tape, okay? So you need some tape, and you're going to get about 4 or 5 pieces of tape. I have clear tape. You can just use whatever kind of tape, blue tape, masking tape, and just put those aside. So I took some tape already, and I just stuck it on the side of the table. And then well, we know that solids, they have some properties. Like if I have this pen here, it's not able to wobble and flow around. If I had an ice cube, I would hold it up and it can't float around. This calculator can't flow around. It's a solid, but it's moving at the same speed, and so we need to hold that solid in place. All the stuff that's a solid, it's held in place. It doesn't flow. And so we're going to take that tape now, and we're going to start putting our fingers in place. So I'm going to take some tape, and I'm going to just start connecting the molecules here. I'm going to put a piece here, connect these two together, okay? Maybe I'll take this piece of tape, and I'll connect. Uh-oh. I forgot to tell you, I would probably use your non-dominant hand as the one that's held together. I'm gonna take another piece here, connect this molecule is getting away. I'm gonna hold this one together now. Okay, like that. Another one here. Holy cow. Okay, so now I have molecules here, and they're still moving, right? Remember, at 0 degrees solid and 0 degrees liquid, they're still moving like this. But now what's different about this? Well, they have these connections between each other. They have these things that are holding them together, and that's kind of like a solid. They're still moving at 0 degrees, but now they're less free to move. And as they start melting, well, how do we melt them now? We gotta keep it at 0. So the movement any different? But now what's gonna happen is, well, this one got away, and maybe, this one now. Now these can be liquids, and these are still solid. Okay. So think about that. You can try that out, and that's how I want you to be thinking about Well, solids and liquids, even though they're at the same temperatures, oh, they're running out of way now. Now I have 3 liquid molecules. They're still moving about the same, even though they're different states of matter.